The table given below shows the amount in grams of carbohydrate, protein, fat and all other nutrients per 100 grams of nutrients in 7 food grains. So, C1, C2, M1, M2, M3, P1, P2. These are the food grains, some code name given. Carbohydrate, protein, fat and other nutrients. So 7 items, 4 different things are being mentioned. The first column shows the food grain category and the second column is its code name. That is, in cereal there are 2, in millets there are 3, in pseudo cereal there are 2. I don't know what pseudo cereal means. Hey, we don't care. Pseudo cereal is pseudo cereal. Lovely. So I get a sense of how the data is presented and we have some missing values. Chances are the missing values are what we need to find. We fill everything up and then we answer a bunch of questions. There are going to be some constraints for finding these missing values. Each of these is for 100 grams. Each of these is given in grams for an overall of 100 grams. That is, if I add these 4, that should be 100. If I add these 4, that should add up to 100. For 100 grams of P1, how many carbohydrates, how many grams of carbohydrates, how many grams of protein, how many grams of fat, how many grams of other nutrients are present. Lovely. Do this. Both the pseudo cereals had higher amounts of carbohydrate as well as higher amounts of protein than any millet. Higher carbs, higher protein than millet. Okay. Both the cereals had higher amounts of carbohydrate than any pseudo cereal. Okay. All the missing values of carbohydrate amounts for all the food grains are non-zero multiples of 5. This one's very powerful because it basically tells us that carbohydrates is 25, 30, 35, 40, 45, 50, 55, 60, something like that. All the missing values of protein, fat and other nutrients for all the food grains are non-zero multiples of 4. Nice. Wherever it is missing, it's non-zero multiples of 4. Wherever it is missing, it's non-zero multiple of 5. Nothing is 0. Whatever is missing, none of that is 0. Some are multiples of 4, some are multiples of 5. This should make life very interesting. P1 contained double the amount of protein that M3 contains. Super. We will capture this data. All the missing values of proteins and other nutrients for all food grains are non-zero multiples of 4. So this is a multiple of 4. 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 All of that. And we know P1 contained double the amount of protein that M3 contains. M3 protein is 4P. P1 should be 8P. So multiple of 8 for good measure. Nice, brilliant. My gut feel is if we can carve open one of these, the others should fall in place. 66 plus 10 is 76. There's a multiple of 8, non-zero multiple of 8 and a multiple of 4. So there's a multiple of 8, the remaining will be a multiple of 4. These two add up to 24. This can be 16 or 24. It can be 8, 16 or 24. It cannot be 24. This will become 0. But it's 8, this is 16, this is 16, this is 8. We keep making inferences like this, we can simplify life. I filled all of this in and we know that this can be attacked really well. P2 likewise opens up some things. 14 plus 8 is 22 plus a multiple of 4. This is a multiple of 5. And we know pseudo cereal had higher amounts of carbohydrate as well as higher amounts of protein than any millet. This is a 56 and a 62. This is more than 62. These two add up to 22. This is more than 62. It's a multiple of 5. These three are even numbers. Should be an even multiple of 5. So it should be 70 or 80. Right? These two add up to 22. This is a 22 plus 80 is 102. Not possible. This should be 70 plus 22, 92 plus 800. We make each inference, we should be able to fill a bunch of data sets like this. And so this is very openable. I think if you look at this, these two numbers, because we know that both the cereals had higher amount of carbohydrate than any pseudo cereal. Pseudo cereal is 66. So this is more than 66. This is more than 66. These two add up to 13. This is more than 66. This is an even number. It should be an odd number. But the total is 100. These two add up to 12. This is an even number. It should be an even number. Even multiple of 5. Odd multiple of 5. More than 66. Such that the rest of the numbers pan out. That will be our next part that we can attack. This is more than 62. This has to be even. Why should this be even? Even. Adding up to 100. This should be even. This has got to be odd. Why odd? Odd, odd, even. Even, odd, even. These three add up to an odd number. Add an odd number to it to get to 100. So this is 75, 85, 95, something like that. It cannot be 95. There's 13 remaining. It can be 75 or 85. If I put 75 plus 13, that is 88. Remaining would be 12. This is 85. 85 plus 13 is 98. Remaining is 2. That's not possible. And or this has to be 75. Likewise here, so an even multiple should be 70, 80 or 90. It cannot be 90. 90 plus 12 is 102. 70 or 80. We put this as 70 plus 12, 82. There's nothing remaining here to be an even multiple of 2, as it should be a multiple of 4. That's not possible. So 70 doesn't work. 80 will work. 80 plus 12, 92. This is 8. 75 plus 13, 88. This is 12. 14 plus 8, 22. Plus 70, 92. This works. Make this 70. That means this is 8. Bunch of data points get filled in. Lovely. So the first one is complete. C1 is complete. C2 is complete. M1 is remaining. M2 is remaining. M3 I think we can attack. P1 we can attack. And so let's see which one falls in place. M2. And so this is 16 plus 7 is 23 plus a multiple of 4. So this has to be an odd number. We know that both the pseudo cereals had higher amounts of carbohydrate as well as higher amount of protein than any millet. Both the cereals had higher amounts of carbohydrate than any pseudo cereal. So higher amounts of protein than any millet. So millet protein should be less than 14. This number should be less than 14. You may be able to find this. Right now we know it's less than 14. 7 plus 16 is 23. So multiple of 4. 4, 8 or 12. 23 plus 4 is 27. Remaining is not a multiple of 5. 23 plus 8 is 31. 23 plus 12 is 35. Brilliant. So this will be the remaining 65. This will be 12. This is in the bag. Here this is still open. So we'll come to this later on. Let's attack P1 next, because if we get this, we can get this. And the pseudo cereals had higher amounts of carbohydrates as well as higher amount of proteins than any millet. So this number is greater than 12. So this is either 16 or 24. 66 plus 10 is 76. 76 plus 24 will become 100. We know that each of these are non-zero multiples of 4. So this one cannot be 0. So this is 16, this is 8. This is 16, this is 8. 56 plus 8, 64 plus 12, 76. This is 24. Nicely done. Let's fill this in. So C1 completely done, C2 completely done, M1 remains, M2 is done, M3 is done, P1 is done, P2 is done. These two add up to 72. 4M plus 4R is 28. There isn't much to do with other. 4M plus 4R is 28. We know that much, but all our constraints are with carbs and proteins. Greater than this, less than that, less than pseudo cereal, higher than carbohydrate, and cereals are pseudo cereals had higher carbohydrates as well as higher protein than millet. Cereals had higher amount of carbohydrate than any pseudo cereal, but our variables and constraints are with carbs and protein across these three. Nothing much to do with fats and others, except that there's a multiples of 4. That doesn't unlock this. Maybe we won't need to unlock it. Maybe we will have something else in the questions. Maybe we won't have to care about it. Coming to this point, I'm very happy to attack the questions. How many food grains had a higher amount of carbohydrate per 100 grams of nutrient than M1? M1 is 62. This is higher, this is higher, this is higher, this is higher, this is higher. 1, 2, 3, 4, 5. How many grams of protein were there in 100 grams of M2? 100 grams of M2 protein is 12 grams. How many grams of other nutrients were there in 100 grams of M3? M3 other nutrients is 24. What is the median of the number of grams of protein in 100 grams of nutrients among these food grains? The smallest is 8, then there is a 10, then 12, 14, 16, median is 12, 12 is our median, done. Median is a middle term when we arrange in order, that is 12. Lovely, nice juicy set. Let's go to the next one. Over the top subscribers of a platform are segregated into 3 categories: kid, elder and others. Kid, elder and others. When I didn't get it, first I thought it was kids and elders. But some of these subscribers used one app and others used multiple apps to access the platform. The figure below shows the percentage of the total number of subscribers in 2023 and 24 who belong to kid and elder categories. And I went through these numbers. This is 15 and 20 adding up to 35%. This is 20 and 30 adding up to 50%. One giant category is still outside. So kid is probably 15 to 18, 15 to or 12 to 21, something like that. Subscribers here can't be 18, can't be 15, maybe 18 to 21. Elder is probably upwards of 60. So there's a big chunk in the middle of useful people. And so that is the other category, the third category. And I don't understand why anyone would categorize like this, but it's not my question, my point to question that. So let's attack this. So these two add up to 35, remaining is 65. These two add up to 50, remaining is 50. Right? Only 2 are given, the third one we can infer. First of all, when you get data like this, I hate bar graphs for the heck of it. This is just like that, like 4 numbers. Why do you need a freaking graph for it? And I won't deal with the graph, I'll put a small table, work with that. And so 15 and 20, 20 and 30, 4 numbers. And so ignore this, capture it in a table, carry on with that. The total number of subscribers increased by 10% from 2023 to 2024. Nice, 2023 is X, 24 will be 1.1X. In 24, half the subscribers from the kid category and 2/3 of the subscribers from elder category subscribers use one app. Others use more than one app. In 23, the number of subscribers from the kid category who used multiple apps was the same as the number of subscribers from the elder category who used one app. Okay, I'll have to keep this in mind. So we're thinking about 23 and 24. We have one as X, one as 1.1X in terms of total. With percentages, we can get kid and elder overall numbers. And then with this half and 1/3, we can get one app and multiple apps. Others we'll worry about later on. 10,000 subscribers from the kid category used one app and 15,000 from the elder category used multiple apps in 2023. And so we're going to say 23, 24, kid, elder, one app, other app, others, total. That's our way of capturing this data. So kid, elder, others for 23 and 24. But we're going to add layers to this. We're going to say, hey, kid, one, more than one. Elder, one, more than one. Others and total. Total will be X and 1.1X. We'll have a kids total, elders total, based on this percentage of this number, and then carry on from there. And that's how data is going to be captured. X, 1.1X, this. So kid, elder, others, we're going to have one app greater than one app greater than one app, with overall numbers being X and 1.1X. And so lovely. In 2024, half the subscribers from the kid category. The kid category is 0.22X totally, 1.1 into 20%. Kid total is 0.22, so half is 0.11. And 2/3 of the subscribers from the elder category. Elder total is 0.33X. Half of this is 0.11, greater than one app is the other half. 2/3 is 0.22, the other one is the other half, the other 1/3 remaining. So that we have got captured beautifully. In 2023, the number of subscribers from the kid category who use multiple apps. for the same number of subscribers from the elder category who used one app. This is Y, this is Y. In 2023, 10,000 subscribers from the kid category used one app and 15,000 from the elder category used multiple apps in 2023. So this is 10,000, this is 15,000. Nicely done. Now this is 0.15x, this is 0.2x. Total is x, 0.15x and 0.2x. 0.15x is 10,000 plus y. 0.2x is 15,000 plus y. The difference between these two, this is 0.15x, this is 0.2x. Difference between these two is 0.05x or 0.05x equals 5,000. I do not have to have complicated equation, these two are equal. From here to here, kid to elder in 2023, 5,000 people more. 10,000 to 15,000, these two are equal. One is 10,000 plus y, other is 15,000 plus y. 5,000 more elders are there in 2023. 0.15x is kids, 0.2x is elders. So 0.05x is the additional, that is 5,000 or x is 100,000. Okay, done. The total number is 100,000. 0.05x is 5,000. The difference between this and this is 5,000. Overall is 100,000. So 0.15x is 15,000. This should be 5,000. This should be 5,000. Okay, done. We can fill everything else after that. The crucial equation is this is 0.15x, this is 0.2x. This to this, the increase is 0.05x. This is 10,000 plus y, this is 15,000 plus y. Here to here, increase is 5,000. 5,000 is 0.05x or x is 100,000. So this total is 15,000, this total is 20,000, this total is 65,000. Can fill everything else. This is 20,000, 30,000, sorry, 22,000, 33,000, 55,000. And everything else can be filled in after this. We do not know the categorization of others between one app and more than one app, either in 23 or in 24. Kid and elder we have, others we don't have. How many subscribers belong to the other category in 2024? These two add up to half. This is the total number. Remaining half is 55,000. 20% plus 30% is half. 110,000 is the total. Half get accounted for with kid and elders. The remaining half, 55,000, is for others. What percentage of subscribers in the kid category used multiple apps in 2023? 2023, 5,000 used multiple apps. Out of 15,000, 1/3, 33.33%. Done. What is the percentage increase in the number of subscribers in the elder category from 2023 to 2024? Elder goes from 20,000 to 33,000. Increase of 13,000 on a base of 20,000, 65%. 13,000 by 20,000 into 100, 130 by 200 into 100, 65%. What could be the minimum percentage of subscribers who used multiple apps in 2024? 2024 is these two. This 55,000 could entirely sit here in exactly one app. That means the minimum number is 20,000 out of 110,000. 22,000 by 110,000 is the minimum percentage. This is 1/5, 20%. The air conditioner in a large room can be operated either in regular mode or in power mode to reduce the temperature. If the AC operates in regular mode, then it brings down the temperature inside the room at a constant rate to set the temperature in 1 hour. It's called inside temperature. So if the temperature is 35 and you set it to 26 and put it in regular mode, it will bring it to 26 in 1 hour. In whatever your target is, it will be achieved in 1 hour uniformly. If it operates in power mode, then it is achieved in 30 minutes. So Existing temperature, target temperature. If it is regular, it reaches in 1 hour. If it is par, it reaches in half an hour. Understandable, beautiful idea. It took me a while to wind my head around this. If the AC is switched off, then the inside temperature rises at a constant rate so as to reach the temperature outside at the time of switching off in 1 hour. Fine, this is very interesting. So if I switch off at 25 degrees and outside is 37, my temperature inside will go from 25 to 37 in 1 hour. It is very much like regular mode, but the opposite way. In regular, your inside temperature reaches target temperature in 1 hour. When it is switched off, then your inside temperature reaches outside temperature in 1 hour. The temperature outside has been falling at a constant rate from 7 p.m. onward until 3 a.m. on a particular night. When I simply didn't understand this, I had to read this segment a bunch of times. Why are we talking about a rate? It's like the evening cools from 7 to 3, temperature drops. For simplifying, we've assumed that it drops at a gentle, consistent rate, maybe half a degree per hour or 0.6 degrees per hour. Slowly it reduces. The following graph shows the inside temperature between 11 p.m. and 2 a.m. that night. Very interesting. Inside temperature. This is 38. This is 26, 31, 26, 30, 28. And 30 should be bang in between 32. Again, I don't understand why a graph has been given. Simple table would have been very nice. I find that there are 6 data points. Looking at a table it helped my mind. Right? The following facts are known about AC operation at night. The AC was turned on for the first time at 11 p.m. 11 p.m. it's turned on. So at 11 p.m. exactly at this 38 degrees Celsius is our temperature. Once it's turned on, the temperature falls to our target temperature. It's either in half an hour or 1 hour depending on the mode. And if it kept it at power mode, it would have reached 32 in half an hour. But the first half an hour could have been in power mode. So it goes from 38 to 32 with a target temperature of 32. One possibility. The AC setting was changed, including turning it on, off, and or setting different temperatures only at the beginning of the hour or at 30 minutes after the hour. This is very interesting. So we could not have said from 11 to 11:15 we'll have power mode. 11:15 to 11:30 we'll have regular mode. We're not doing that. So we're changing the setting, either the mode or the target temperature or on off, whatever it may be, only at exact half hour points. 11, 11:30, 12, 12:30, 1, 1:30. 2 we don't care. At 2 we've stopped measuring. The AC was used in power mode for longer duration than in regular mode during this 3-hour period. Power mode for longer than regular mode during this 3-hour period. Very interesting. We switched on this AC at 11 o'clock, which is why the temperature falls to some target temperature. Now, very interestingly, when it operates in regular mode, it brings down the temperature inside the room at a constant rate to the set temperature. If it operates in power mode, it brings it down. If the AC is switched off, then the inside temperature rises at a constant pace. One very, very interesting, very seemingly obvious, but something we need to verify very well here is when the AC is on, the temperature drops either at the regular rate or at the power rate. It's fast. When the AC is off, then the temperature rises. So first of all, we can notice that the temperature rises from 12 to 12:30 and 1 to 1:30. That means at 12 it has been switched off. So at 12 we switch it off. At 1 it has been switched off. At 11:30 it continues to be on. Maybe the mode has been changed, but it is on. At 12:30 we turn it on, we switch it on, we off and then we turn it on. At 1:30 it is turned on because the temperature falls. So it is switched on from 11 to 12, switched off from 12 to 12:30, on again from 12:30 to 1, off from 1 to 1:30, on from 1:30 to 2. Whether it's switched off at 2 or switched on at 2, doesn't matter. I struggled. I want to write down this thing and have my OCDs. I want to finish this table. Like at 2 o'clock, will they switch it off or on? Doesn't matter. We don't care. But I was worried. I was like, this is the table. How am I not able to put this in? And so it doesn't matter. The first step. And then at each of these ranges, we know this off on setting. We can think about the mode also. We can say, hey, this is at this time it is on, here it is off. At 11 o'clock to 11:30, it's dropped by 6 degrees Celsius. So I could have set the target temperature as 32 and run this in power mode, or set the target temperature at 26 and run it at regular mode. And so it is dropping 6 degrees in half an hour. Either I could have set my target temperature at 32, in half an hour I'll reach 32, or it is dropping 6 degrees in half an hour, but my rate is for it to drop by 12 degrees over an hour. 38 to 26 I wanted to do aram se over 1 hour. First half an hour it will drop 6 degrees. It would have been in regular mode. And so the mode we'll still have to figure out, but the on off thing we can do straight away. The on off thing we can do done. Right? Now the next thing that we would like to attack is this outside temperature. Very interesting dynamic. And so at 26 it is off, and then it wants to catch up with external temperature in 1 hour. Right? It drops by 5 degrees Celsius in half an hour. Sorry, it increases by 5 degrees Celsius, not drops by. Pardon my language. Next half an hour, when it is switched off, it increases by 5 degrees Celsius. It is wired to catch up with external temperature in 1 hour. It increases by 5 degrees Celsius in half an hour. If it had continued to be like this, it would have increased by another 5 degrees Celsius in 1 hour, when it would have reached the external temperature at the 12 o'clock time, or at 12 o'clock time, the outside temperature is 36. Quite beautiful, because it increases by 5 degrees in half an hour. It would have increased by 10 degrees in 1 hour. When it is switched off, it says, what is my difference between current temperature and outside temperature? I want to bridge that gap in 1 hour. It is bridging 10 degrees in 1 hour, or the gap should have been 10 degrees Celsius, or the external temperature at 12 o'clock should have been 36. Nice, beautiful. The same funda we can apply here. From here to here, it increases by 4 degrees Celsius. So that means it's operating at an understood rate of 8 degrees per hour. That means the difference between this and external should have been 8, or external temperature at 1 o'clock exactly should have been 34. Now we've come to that point where it is beautifully mentioned that from 7 p.m. to 3 a.m. it uniformly falls. So 36 at 12, 34 at 1, 35 here, 33, 32, 37, 38, 39, 40, 41, 42 before that, all of that. And after this it goes to 31, 30. External temperature drops at the rate of 1 degrees per every half an hour, and it happened to be 38 degrees Celsius at 11 o'clock, gently falling to 32 by 2 o'clock. Nice, brilliant. Here there is no mode. Here there is no target temperature. Switched off. Now is where it gets very interesting, because we know that the power mode was for longer duration than regular mode. Totally the AC is on for 4 hours. 11 to 11:30, 11:30 to 12, 12:30 to 1, 1:30 to 2. Right, so this half an hour stretch, half an hour stretch, half an hour stretch, half an hour stretch. Right, so 11 to 2 is 3 hours. It sleeps, or it switched off for 1 hour. Remaining 4 slots of half an hour it is on. The power mode is for longer duration than regular mode. So power and regular could have been 3-1 or 4-0. 3 slots of power mode, 1 slot of regular mode, or 4 slots of power mode, 1 slot of regular, 0 slots of regular mode. And 4 of power mode, that means all of these are power mode. on and kept on power, on and kept on power, on and kept on power mode, on and kept on power mode. That means 38 to 32 it goes in half an hour, target temperature is 32. 32 to 26 in half an hour, 26. 31 to 26 in half an hour, target temperature 26. 30 to 28 in half an hour, target temperature 28. This is one possibility. Another possibility, there are 3 power modes, 3 slots of power modes and 1 of regular. It's slightly trickier because then the regular mode could have been here, here, here or here. The other 3 being power. That's another possibility. Fine. That's a possibility, frankly, I'm going to say, hey, I'm not going to worry about right now. I've got the hang of this. I know that there could have been 4 power modes and 0 regular modes, 4 slots of half an hour power modes and 0 slots of half an hour of regular mode, or 3-1. Cannot be 2-2 or 1-3. That's not possible. So we say, hey, nice. Let me hold on to this now and attack the questions. How many times the AC must have been turned off between 11 and 1:59? How many times is it turned off? Exactly at 12, exactly at 1, turned off twice. What are the temperature outside in degrees Celsius at 1 a.m.? At 1 a.m. outside temperature 34. What are the temperature outside in degrees Celsius at 9 p.m.? 38 at 11, 2 degrees every hour, but this time it should be higher than 38 because it's falling through the air. So at 10 it would have been 40, at 9 it would have been 42 degrees Celsius. What best can be calculated? The number of times the AC must have been either turned on or the AC temperature setting been altered between 11:01 p.m. and 1:59 a.m. Turned on or altered. Turned on definitely at this slot. At 11 o'clock it is switched on. From 11:01 p.m. At 12:30 it is switched on for sure. At 1:30 it is switched on for sure. Twice it happens for sure. At 11 it is switched on. At 12 and 1 it is switched off. We won't count. Nice, brilliant. So we are talking about 11:01 p.m. 11 o'clock it is switched on, but that won't get counted. And we know all the changes happen at the half hour or the full hour. So we're talking about 11:30, 12, 12:30, 1, 1:30. 5 possibilities. 11:30, 12, 12:30, 1, 1:30. What happened at these times? Right? 2 of those times, 12 and 1, it has been switched off. 2 of those times, 12:30 and 1:30, it has been switched on. These 4 points are very clear. This entire question now hinges on, hey, what happens at 11:30? At 11:30, it continues to be on. That we know. Right? So, does the setting change, or is there a possibility the setting need not have changed? Right? So, one is it could have been on at 2300. It could have been on with power mode here. Then the target temperature would have been 32 and then continued to be at power mode with target temperature at 26. This is a possibility. You already have seen this. That means there is a change at 11:30 which changed the setting to change the target temperature. And so that means we have tinkered with the setting. We have gone and done something with the AC remote by switching it on or changing the setting on 3 occasions: 11:30, 12:30, 1:30. At 12 and 1 we switch off. Switching off we don't count. Now this whole question now comes back to, hey, is there a scenario where we know that here it is switched on, here it is switched on. Is there a scenario where I'm not doing anything at 11:30? 11 o'clock I create a setting and then at 12 I switch it off. Is that possible? It is at 11 o'clock I switch it on. Is there a possibility at 11:30 I don't do anything? Think about it. At 11 I could have set it as, if I set it at power then I have to change it. If I set it at regular mode, it reaches 32 here. I could have set a target temperature of 26. Then in half an hour, it will drop by 6 degrees Celsius. Go to 32, can continue to be in regular mode. I don't do anything. It reaches 26. Quite beautifully, this can happen. That means at 11:30, I don't touch. At 11, I've set it at regular mode with target temperature of 26. It will go to 26 by 12 o'clock. Passing through 32 at 11:30, all brilliant, it works out fine. There is one possible scenario where both could be regular with target temperature of 26, where I don't touch the remote at all at 11:30, except if this happens, it stays in regular mode for 1 hour, in power mode for 1 hour, and we know for a fact that it stays on power mode longer than it does for regular mode. So it is impossible that we had a setting like this. That means we should have tinkered with it at 11:30. We definitely tinkered with it at 12:30 and 1:30. We should have definitely tinkered with it at 11:30 also. At 12 and 1, we switch it off. Those don't count. These three count exactly 3 times. Beautiful question, because this is a very close, seemingly delicious option. This is the right one. What is the maximum difference between temperature outside and inside temperature in degrees Celsius between 11:1 and 1:59? So outside temperature and inside temperature. So this is 38 and 38, very small. Gently it comes here. 32 and 37, 5 degrees. 26 and 36, 10 degrees here. 31 and 35, small. 26 and 34, 8. 30 and 33, 3, 4. This seems to be the highest. I still have to worry a little bit. So it has fallen to 26. 32 to 26. It falls from 37 to 36. So just let's say 11:55. What will be the temperature? This will be more than 26. That will be more than 36. But this is falling at a higher rate. So the maximum difference will happen when this is 26 than that. So I have to worry that at 12 o'clock the difference is 10 degrees. What happens at 11:55? This will be more than 26, this will be more than 36. But this will be much more than 26, then this is about 36. Difference will be less than 10, not more than 10. I just wanted to worry about that. That is taken care of. In other places it won't catch up. 26, after 26, it goes from 26 to 31 in half an hour. It goes from 36 to 35 in half an hour. This is increasing, that is reducing. My gap will reduce. I don't worry about it. Maximum difference in temperature is 10 degrees Celsius. Out of 10 countries, country 1 through country 10, country 9 has the highest gross domestic product and country 10 has the highest GDP per capita. Very interesting ideas. Very often we haggle over GDP. GDP per capita is the ball game. And so that's lifestyle. Having 1 million people produce something is obviously good, but if you can do this with 200,000 people, that's brilliant. So GDP per capita is a very important, very real metric. GDP per capita is the GDP of a country divided by its population. The table below provides the following data about country 1 through country 8. 10 countries, but 1 through 8 is given. Column 1 gives the country's identity. Maybe it's India, Japan, Singapore, etc. Column 2 gives the country's GDP as a fraction of GDP of country 9. Column 3 gives the country's GDP per capita as a fraction of the GDP per capita of country 10. So 9 is the benchmark for GDP, 10 is the benchmark for GDP per capita. Column 4 gives the country's annual GDP growth rate. Column 5 gives the country's annual population growth rate. Okay, nice. I think if you see the table, this will make sense. Okay. Country 9 has the highest gross domestic product. Country 10 has the highest GDP per capita. So if country 9's GDP were 100, then country 1's GDP would be 15. 0.15 times 100. Country 8 GDP would be 7. 0.07 times 100. Country 10's GDP per capita, if that were 1000, then GDP per capita would be 410. 0.41 into 1000. And so country 9 is the benchmark for this maximum GDP. Country 10 is the benchmark for GDP per capita, maximum GDP per capita. Then GDP growth rate 0.2, 0.9, 6.5, 0.5, 0.7. Population growth rate minus 0.12, minus 0.1141, 0.7, 0.49. Some are growing, some are shrinking population wise. Interesting. I don't have a sense of what we are solving for. We'll have to see the questions for that. But it's not like a puzzle. It's like a math computation thing. Assume the GDP growth rates and population growth rates of the countries will remain constant for the next 3 years. This year, next year, year after that. This year, next year, year after that. Same numbers, same growth rates. Interesting. Let's go look at the questions. And before that, we've got to put all these data in here. We know that country 9 has the maximum GDP. We put C9, call this X, and put C10, call that as Y. If you do that, then this is 0.15x, 0.14x, 0.13x, 0.12x, 0.1x, 0.41y, 0.25y, 0.02y, y. We can get all of these in terms of x and y. If we know x, we know everything. We can find ratios of two things. All of that we've got. X and y, we've got this completely filled. We cannot do anything more than that. We've got all these numbers. We have to look at the questions and see where they take us. Which one among the countries 1 through 8 has the smallest population in 2024? This is GDP. This is GDP per population. GDP divided by GDP per population is equal to population. Nice. I have GDP divided by per capita GDP. I'll get population. So I'm going to do this by this. We want to find the smallest population. First thing to notice and grab onto this really comfortably is that this question has nothing to do with x and y. If x were 1000, y were 45, or x were 0.02 and y were 10 power minus 11, the lowest will be the same, highest will be the same, whatever we are calculating. Fine. So that's very important to grab onto. Which of the following has the smallest population? Country C3, 0.13 by 0.02. Just by that, GDP by 0.13 by 0.02, x by y. X by y is going to be constant or the same fixture throughout. Country 5, 0.1 by 0.36, x by y. Country 8, 0.07 by 0.41, x by y. Straight away so far that is 13 by 2, this is 10 by 36, this is not 10 by 36, 7 by 41, lower numerator, higher denominator. So far this is the smallest, 7 by 41. Country 7 is 8 by 30 times x by y. This is 7 by 41, that is 8 by 30, both multiplied by x by y. X by y is a nice positive number, real number. I don't care what it is, it won't matter. My answer is 7 by 41. 7 by 41 is definitely lesser than 8 by 30. I don't have to put pen on paper, I don't have to calculate, don't punch in using a calculator and find all these values. It's a pain and something can go wrong. 7 by 41, smaller numerator, greater denominator, that is lesser. Country 8, done. The ratio of country 4's GDP to country 5's GDP in 2026 will be closest to country 4, country 5. Right, so all these numbers are through which year? Let me just check that. Country 1 through for the year 2024. For the year 2026 is what we need to find the ratio. That means 2 more years. This is getting done twice over. The rates are constant. And so country 4 to country 5, this is 12 is to 10, 6 is to 5 to start with. This grows by 0.5, this goes by 0.7. So I'm thinking about 12 into 1.005 whole square by 10 into 1.007 whole square. Just like how we would do compound interest. 0.5%, 0.7%. Right? So 12 by 10 is 1.2. I'm looking at an answer very close to 1.2. These two are very linked. I'm looking at an answer close to 1.2. The only thing I need to process is my ratio going to be less than 1.2 or more than 1.2. This is less than this. It will be less than 1.2. Slightly less than 1.2. So don't calculate this. Pain. I'm looking at 1.2 and saying this currently it is 1.2 and my country 4 is growing slightly slower than country 5. the ratio will become slightly less than 1.2. Whatever that is slightly less than 1 is only one choice, mark it, good to go. Which one among the following countries 1, 4, 5 and 7 has the largest population in 2027? So country 4, just by this, I'm going to take the initial ratios 12 by 38, 0.12, 0.38, country 7, 8 by 30, country 1, 15 by 41, country 5, 10 by 36. Nice, so far so good. And then 3 more years. But if you notice, all these population growths are in plus or minus 0.5%. Either 0.995 or 1.005 whole cube. That's not going to be wildly different. That's going to change numbers by 1%, 0.5% up and down. These numbers, if I have a clear winner in terms of largest, I'm through. Right? So 12 by 38, 8 by 30, 12 by 38 is higher. This is smaller. 15 by 41, numerator grows up by a higher part, so smaller. 10 by 36, 15 by 41 is higher. 15 by 41 is my highest. 15 by 41 here, practically flat, minus, but minus 0.12%. 3 years. This is practically flat. Can it catch up with this? My gut feel is no. Technically, what should I be doing? 15 by 41 into 1 minus 0.0012 whole cube. 12 by 38 into 1 plus 0.0049 whole cube. 8 by 30, this is country 7, into 1 minus 0.0011 whole cube. And find all of that. Fine. So all of these numbers are going to be freakishly close to 1 plus or minus 2%. 15 by 41 is way higher than 8 by 30. It's more than 12 by 38. It's more than 10 by 36. It is sufficiently large that I'm not even worried about this swing, marking that confidently. Answer choice C, country 1. How many countries among country 1 through 8 will the GDP per capita in 2027 be lower than that in 2024? GDP per capita. My GDP can be growing, my population can be growing. If GDP grows more than population, my GDP per capita will increase. If GDP grows but population grows even more, my GDP per capita will decrease. This question, a roundabout way of asking, in how many countries GDP per capita is lower? In how many countries is GDP growth rate less than population growth rate? GDP has grown, population has grown by more, per capita will crash. In how many cases is this number, is this less than this? In how many instances? 0.2 minus 0.12, 0.9 minus 0.41. All the negatives, all these are positive, negatives I remove. 6.5, 0.7, no. 0.5, 0.49, close, but no. 0.7, 0.31, no. 3.2, 0.61, no. 1.2 points. All of these countries, whether they've grown really well or only mildly, GDP growth rates have been higher than population growth rate, or GDP per capita will increase, not decrease. How many cases will it be lower? 0. The figure below shows a network with 3 parallel roads represented by horizontal lines RA, RB and RC, and another 3 parallel roads represented by vertical lines V1, V2 and V3. Let me see the diagram. RA, RB, RC, V1, V2, V3. The figure also shows the distance in kilometers between 2 adjacent intersections. Nice. 4 and 7, 3 and 5. This is 4, 7, 4, 7, 3, 5, 3, 5. Simple rectangles. We're not dealing with anything complicated. 6 ATMs are placed at 6 of the 9 road intersections. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. 6 are placed. That means 3 should be empty. Each ATM has a distinct integer cash requirement in rupees lakhs. And the numbers at the end of each line in the figure indicate the total cash requirements for all ATMs placed on the corresponding road. Right? For example, total cash requirement of ATM placed on road RA is 22 lakhs. This is 22 lakhs. All of this put together is 20 lakhs. These put together is 20 lakhs. 15, 21, 26. The first thing I do in all of these questions is add these three and check which adds up to these three. 20 plus 20, 40, 62. 36, 62. Yes, it works. My mind is at ease. All 6 put together adds up to 62. Fine, lovely. The following additional information is known. The ATMs with the minimum and maximum cash requirements of rupees 7 lakhs and 15 lakhs are placed on the same road. 7 and 15 are placed on the same road. 7 is the minimum, 15 is the maximum. Integer cash values, distinct integer cash requirement in lakhs. Super. So our numbers are 7, 8, 9, 10, 11 till 15. 9 different values. Of these values, only 6 are taken. 7 and 15 are definitely taken. 4 more values are there. Okay. The road distance between the ATM with the second highest cash requirement and the ATM located at the distance of RC and V3 is 12 kilometers. RC and V3. RC and V3 from here to second highest requirement is 12 kilometers. This is 5 plus 7. This would be 12. This is just 7. To here would be 11. 11 plus 3 is 16. This is higher, this is higher. This is 5, this is 8. Only this one is 12. The one bang in between has an ATM in it. It is the second highest cash requirement. Nice. So this one, second highest. Lovely. Now, this is also a very useful constraint. The ATMs with the minimum and maximum cash requirements, 7 and 15, are on the same road. Either RA or B or RC, or V1, V2 or V3. 7 plus 15 is 22. So 7 and 15 cannot be here, cannot be here. Can be here, cannot be here, cannot be here. Either here or here. Cannot be here because 7 and 15, if they were there, then the third one has to be, if there is a third one, there has to be a third one. 7 plus 15 is 22, third one has to be 4. Minimum will become 4, minimum is 7. So 7 and 15 are in this row. RA has 7 and 15 in it. 7 and 15 are on RA. This is 15. 7 and 15 are present here. How can we achieve 15? 15 can be 7 plus 8. Minimum is 7. Minimum total possible is 7 plus 8, 15. Nothing else is possible. And 15 can be achieved only as 7 plus 8. No other combo can be 15. Or at least that's what I thought. What I completely missed out and messed up in this set is this 15 could be just 115. So this number 15 is a crucial thing to unlock this whole thing. This could be just 115 or it could be 7 plus 8. So there could be only one ATM on this V1 which has a requirement of 15 lakhs or two ATMs on V1 which have requirement of 7 and 8. Both are possible. We have to keep both of them in mind. I completely ignored this and paid the price rather heavily. 7 or 8 or only 15. If it is only 15, 15 has to be here. If it is 7 or 8, this has to be 7. So the V1 and RA intersection has to have an ATM and that has to be either 7 or 15. Both are possible. Right now, so put it as 7, put it as 15. Maybe one of these will get eliminated. This is 15. This overall adds up to 15. So nothing here, nothing here. Okay. If this is 7, there's one more 15 that is there on this row. This is the second highest. If the 15 were here, this will be 6. 6 is not second highest. 6 is not even possible. So the 15 can't be here. 15 has to be here. In this case, both of these have to be empty. In this case, the 15 has to be here. Okay. Let's put both of them in. This is 15, this is 7. There is a second highest that is sitting bang in between in both of these cases. In this case, this is empty, this is empty. What do we find for ourselves here? If this is 15, only 11 remaining for this road, for this column, for V3. 11 cannot be from 2 ATMs, the minimum is 7. So 11 has to be from 1. So if this were 11, then this adds up to 20, this is 11, this has to be 9. This won't be the second highest. So that is not 11, that means this has to be 11. This has to be 11 and there's nothing here. Nice, brilliant. This cannot be 20, so there has to be something here. We know what, this cannot be empty. So this has to be 8. This has to be empty. This is 8, this adds up to 20. This has to be 12. 12 is the second highest. 7 plus 15 is 22. There's nothing here, nothing here, nothing here. This is 12, adds up to 21. It should be 9. 9 plus 11 is 20. This possibility is completely filled beautifully. If that indeed turns out to be correct and only one, this takes care of itself and gets cancelled, we'll be very happy. Right? Now we put 15 here, we still need to locate the 7. The 7 could be here, in which case the other two should add up to 14. That means this should be 14, there should be nothing here. This is 14, nothing here. This has to be 6. This is not possible. Why is this not possible? Because if this were 6, 6 would be the minimum. Minimum has to be 7. Right? These two are empty. This column has only 1. Some column should have 3. This can't be 7 because 7 plus 14, 21. This has to be empty. Therefore, these two both can't be occupied because we have 7, 7, 7. That's not possible. Each number is unique. This is 7, this is 6. That is not possible. So this is not the situation. We have a scenario where we say, hey, this is not 7. We'll have to figure out where this has to be 7. In which case, this is empty. These two add up to 20. These two add up to 19. Plus 7, 22. This is not empty. 15 plus 7 is 22. Suppose we say this is P, Q, R, S. We know that P plus Q is 20. R plus S is 20. Q plus S is 19 because 7 is gone. P plus R is 21. This is second highest. This is 20. This has to be large. 14 plus 6 doesn't work. 13 plus 7 doesn't work. 12 plus 8 could work. 11 and 9 could work. 10 and 10 won't happen. So it could be either 12 and 8 or 11 and 9. If this were 12, these two add up to 21. Should be 9. These two add up to 20. Should be 11. 12, 8, 9, 11. That works. If this were 11, this should be 10. 10 plus 10, 20. 10 plus 10 can't be the scenario. 10 will repeat. That is not possible. So this number cannot be 11 and 9. It has to be 12 and 8. These two numbers. If it were 11 and 9, 7 plus 9, 16. This has to be 10. 11 plus 10, 21. This has to be 10. 10 and 10. That repeats. That is not possible. So 11, 9 is not possible. 13, 7 is not possible. 10, 10 is not possible. It has to be 12 and 8. The moment we put 12 and 8, the other two fill themselves, 9 and 11. Interestingly, both of these are possible. Right? 7 plus 15, 22. 8 plus 12, 20. 9 plus 11, 20. 7, 8, 9, 11, 12, 15. All distinct. 6 ATMs works. 15 plus 7, 22. 12 plus 8, 20. 9 plus 11, 20. 15. 12 plus 9, 21. 7 plus 8 plus 11, 26. 8 distinct numbers, 6 distinct numbers, 7, 8, 9, 11, 12, 15. Brilliant. So both of these are possible. Now we say, hey, both are possible. Let's attempt these questions. Which of the following statements is correct? The ATM placed at RCV2 junction has a cash requirement of 9 lakhs. That's correct. I'm going to still eliminate the others. The ATM placed at there is no ATM placed at RCV2. That's not the case. The ATM placed at RCV2 intersection has a cash requirement of 8 lakh. That's not the case. The cash requirement of the ACM placed at RCV2 intersection cannot be uniquely determined. Not the case. It can be. It is 9. Choice A. How many ATMs have cash requirements of 10 or more? This one, this one, this one. Not 7, 8, 9, 11, 12, 15. 15, 12, 11. Not 7, 8, 9. 3 in both cases. Answer is 3. Luckily for us, in both cases the answer is same. Which of the following two statements are definitely true? Each of RA, RB and RC has 2 ATMs. RA2, RB2, RC2. RA2, RB2, RC2. Yes, statement A is true. Statement B, each of V1, V2 and V3 has 2 ATMs. 2, 2, 2, 1, 2, 3. Statement 2 is not true. This situation can be there. Where in V1 there is only 1 ATM, V3 has 3. Statement A is true, but not B. What best can be said about the road distance between the ATMs having the second highest and second lowest cash requirements? Second highest is 12, second lowest is 8. 7, 8, 9, 15, 12, 11. This distance is 4. Second highest is 12, second lowest is again 8. This is 7. The distance could be 4, distance could be 7. Both of these are possible. We're looking for an answer choice. This. What are the number of ATMs whose locations and cash requirements can both be uniquely determined? It's 12 in the middle, both cases. 11 here, both cases. 9 here, both cases. 3 are in the bag. 15 is this side and this side, not possible. 7 is here and here, not possible. 8 is here and here, not possible. 3 work, 3 don't work. Answer 3.